What stationarity is. Stationarity is an important characteristic of time series. If statistical properties of time series do not change over time, then a time series is said to be stationary. In other words, it has constant mean and variance, and covariance is independent of time. Look at the given graph plot. We see that the process above is stationary as the mean and variance do not vary over time. When can you say that a series is a non-stationary? A series is non-stationary when it has any of the following issues: an increasing trend that leads to a non-constant mean, as shown in the first graph. Covariance is not constant with time, as shown in the second graph. Irregular pattern that leads to a non-constant variance, as shown in the third graph. Let's understand which method will help you do a stationarity check of your data set. If you want to do the visual stationarity check, you can apply rolling statistics over your data sets. A simple rolling average, also called a moving average, is the unweighted mean of the last n values. A rolling average can help you find trends that are hard to detect. Plot the moving average or moving variance to check if it varies with time. In the given graph, you can see that the mean and variance increase constantly, so visually, using rolling statistics, you can do stationarity check. Now, if you want to perform a statistical stationarity check, you can apply the Dickey-Fuller test on your data set. Dickey-Fuller checks the null hypothesis by checking that the time series has root and is stationary as well. Otherwise, it rejects this hypothesis. Null hypothesis is the test statistics value and is non-stationary in the given example. Dickey-Fuller checks for the condition if test statistics is less than the critical value. In such cases, when it is true, it rejects the null hypothesis. How can you remove the non-stationarity from your data set? You can do that using the two techniques, differencing and decomposition. Getting the test statistics to be perfectly stationary is desirable but not practical, so it is made as close as possible to stationary using these statistical techniques. So, let's first look at differencing. Differencing is used to make the series stationary, to detrend, and to control the autocorrelations. However, sometimes series analyses do not require differencing, and over-differenced series can produce inaccurate estimates. It is performed by subtracting the previous observation from the current observation. Equation for differencing is delta y of t is equal to y of t minus y of t minus 1, where delta y of t is the difference between two successive values. Y of t is the value of y at time t, and y of t minus 1 is the value preceding y of t. You can observe the effect of differencing by looking at the two given graphs. The first graph contains non-stationary series. After applying differencing on the same series, the series has become somewhat stationary, as it is practically not possible to make it 100% stationary. Now let's understand decomposition. Decomposition refers to separating a time series into trend, seasonal effects, and remaining variability assumptions. Detrending or deseasonalizing eliminates the trend and seasonality respectively. Decomposition is performed on the original series by regressing the series on time and taking the residuals from the regression. You can look at the given graph and observe the impact of decomposition. You can also use techniques like transformation, which penalize higher values more than the lower values, such as square root, cube root, log, etc. Demo Air Passengers 1. Problem statement. We are given consists of monthly totals of international airline passengers between 1949 to 1960. The objective of this analysis and modeling is to review time series theory. We will be following an ARIMA modeling procedure of the air passengers dataset as follows. 1. Perform exploratory data analysis. 2. Decomposition of data. 3. Test the stationarity. Let us import the required libraries and load the dataset in Pandas data frame. Importing NumPy. Import NumPy as NP. Importing Pandas data frame. Import Pandas as PD. From datetime, import datetime as DT. Importing stationarity test libraries for evaluating the time series. From statsmodels.tsa.stattools, import add Fuller, ACF, PACF. Importing ARIMA from statsmodels. From statsmodels.tsa.arima_model, import ARIMA. Importing math library. Import math. Importing matplotlib. Import matplotlib.pyplot as PLT. Percentage matplotlib inline. Importing RC params from pylab. Importing warning library to disable Python warnings. Import warnings, warnings.filter warnings, ignore. Now let's load and read the dataset in Pandas data frame. The dataset consists of the date and monthly passenger count values. Let's display the total monthly passenger count. Using the lambda function to filter month, plot, setting the index to month. Now let's see the data once. Assigning the passenger's data time series variable. Plotting the time series we get. It's clear from the plot that there is an overall increase in the trend with some seasonality in it. Transforming series